catch up later on anyway.
We'll be there. So get ready.
Yeah, once you get don't take that first.
You're welcome.
Welcome to Turn Right Machine Works, and my name is Keith. Welcome to the Bar Z Summer Bash 2016, and I'm going to go ahead and I'm going to demonstrate my marine shaft straightening. It doesn't mean that it needs to be a marine shaft. It can be a shaft of any kind, and what I'm going to do is actually I'm going to need a participant that will set this dial where I put it, and I'm going to be moving this one here, and I'm going to be creating a straightening technique right here in the on the shaft itself. I'm going to be doing some heating. I'm going to be spraying with the hose here. So I got a piece of plastic here, and if anybody wants to hold up the plastic in front of you to keep the spray off, because I'm not sure how it's going to react here. What I normally do when I first set up and I'm doing shaft work, I'm going ahead and I'm setting up and I'm going to map out my shaft. So I know basically you don't have to actually set it at 0. I mean, you can look at it and you can count where you're at here. But I marked the high here, so we got like 9. And I'll come down here, and what you're doing, you're mapping it out, because it's not necessarily total amount of run out, but where the run out is in relationship to your zeros. Your 0 here and your 0 here, just like a B block, except for you're in the rollers. So here we got there's about 13 or 14 there. We were 9 there, and the crisscross points of these are showing you where the run out is in relationship to the position on shaft, as far as 12 o'clock, 1 o'clock, you know, around there, because you can have a shaft it's not just bowed, but it might be actually twisted. So you're gonna be looking for both of those points there as well. All right, we got 17 here. All right, and we're down to about 7 or 8 right here. So you can see it does have this 14 here is a little bit off of that one there. So it's not too much of a twist. This is pretty much of a gradual bend right here, and 17 is your high. After you get that, if you wanted to, you could search and actually get and find out if you actually have like a 19, 18 or whatever it's at, real close to that 17. But we'll go ahead and I'm going to set this up so I can see this here. What we're going to do is we're going to go ahead and we're going to take that 17 down. All right, so I'm going to ask you to go ahead and set that indicator at 0. You know, within a half a thousand or so. So it's coming up, and I got about 17 there. You about 17 on that side?
Yeah, I got about 11.
11? Okay, and I'm about 15 or 16 on the side here. So what I'm going to do is I'm going to go ahead and we're working the high on the shaft here, and we're actually going to go ahead and we're going to heat that up. I've already turned my bottles on, and you will have mist or water going that way, so if you want that plastic up in front of you. Now when you're working on a shaft for the very first time, your first test indicates how much heat, how much cooling takes to do the job. You're watching your indicator, you're watching the speed that your indicator is going. All right, now that heat straightening went ahead and reset at 0. You know, when you get accustomed to this and you're going, you just kind of like, I won't even bother setting my dial at 0, because you're looking at the high and low and you're remembering where you're at. but we brought that down. I'm at 11 now. What are you on that one?
We're at 8.
Okay. All right. Okay, reset it at 0. Okay, I'm about 6 there.
Okay, we're at 3.
Okay. I'm going to go ahead and I'm going to go on this side of the indicator here now, just because I know that we've got a graduation that's more over here. I mean, we can map up and down here, but I'm going to go ahead and switch over to this side right here.
What's that?
Okay.
Compressed air and cold water?
Yeah, that's all it is. Okay, she should be rolling pretty true within 1,000 or so. Okay.
Well, 2,000.
Yeah.
1,000.
Now, when you're setting, what you're doing is you're setting it, and the reason why this works is because this is like when you have hot water, hot boiling water, and you throw it up into 0 degrees or a little bit less, and it instantly freezes. The water being put on there is actually the hotter section of the spot you're heating is contracting faster than the rest of the metal, and that's what gets you the pull on the other side. That's as simple as I can put it right there in English right there. All right, so, and then what I do is I'll let it sit there and normalize and come back to it if I need to, and then I might also go ahead and start hitting another area here. Now I'm running up and down about 3 or 4 right there. You got about the same there?
Yeah.
Okay, that would be your high right there?
Yep.
Now the reason why we're doing this underneath the shelter and everything else is because you cannot do this in the sunshine. You have the shaft out in the sunshine, and while we're talking, you can actually physically watch that indicator climb, as it's sitting there. And if you rolled it over, it would climb and go back to the other direction there.
What causes these things to bend when they're in the boat?
Usually hitting ground. The bottom comes up and smacks your boat, there's a lot of things. I mean, you could wrap a buoy in, anything that causes stress on the shaft or whatever. But this, I'm known for marine shafting, but you could be, pump shafting, any kind of shafting that you're going to be working with that the outside is finished. It's going to be a finish. You want it to run perfectly true, and then when you put it in and it's important to straighten all your material.
Now I have a motor that has 2 arbors on it, and it's for grinding drills. It's a little precision motor.
Yep.
And it's out of round. Can I take the armature out and set it up like this?
Yes, you could. I'm using this is grade 316 stainless steel, but it could be 304, 30 whatever. But I ordered this because I knew that it automatically would come with some kind of run out. It never comes perfect. In fact, actually, you can see this is the factory end here, and it's a little straighter now that I've straightened this out. And whenever you work this, and then you've got to go out there. But I knew that it was going to run out. Now steel has got more carbon in it, and it'll still react the same way, but it'll be much slower. You'll have every alloy is going to be a little bit different. Now the safety as far as being able to do a heat straightening on here, every alloy is going to have a different standard, whether it's going to have to be stress relieved or annealed afterwards, and you basically can use what welding requirements are, as if you were welding on this piece of material. So I could do a weld fusion overlay on this, undercut this, weld it up, and then remachine it. And and incorporate the heat straightening all at the same time. Whereas like, let's say Aquamet 17 is a type of marine shafting, and it actually has more carbon in it, and you actually have to go through stress relieving on the project after you do the weld procedure. So you know, it all pertains to what your alloy that you're straightening.
How thick of material could you do this to?
4, 5, 6 inch shafting. Yeah, it doesn't matter.
The heating, how much heat you put in that?
That's why I said when I first start, your first test is actually how fast is that indicator going. The faster the indicator is going, the faster it's going to respond back down. So you know, if you see that thing take off, okay, back off onto it. So, but you know, I've been doing this for 20 plus years. Okay, so but I learned just like you're learning right now from a mentor, and sat me down and put that in my hand and put the torch in my hand and start. And it's time takes time, but this is what it's about, and that's what these are about too. The rollers is not. The rollers are designed so that you don't have to. You could put it on the concrete. You could put it on a wood ramp, a deck, or whatever. One can be higher than the other. In fact, actually, lots of times I will jack one up if you wanted to check the face run out on the coupling. So if you're doing a shaft check, and it doesn't matter if it's a pump coupling or whatever, you can jack one up, put a ball bearing with a square, clamp to the table, let it ride on the ball bearing, which creates your thrust. And then you can put your indicator, swing it, and read your face.
So Keith, this piece of shafting is probably, guessing, started out with a gradual bow over the whole thing.
Yeah, it had a little twist, and of course I don't have a long enough table to go ahead and express the end.
You created a couple of specific stress points that tended to undo that bow.
Yeah,
but you
yeah.
really haven't done anything except at those points, have you?
That's it. Those points have drawn in and set the hold at those points.
At those points, and so it's kind of bowed, but with points that kink it back.
Oh, if you wanted to put it like a CAD program and your nodes on an arc, is that what you're trying to?
Well, kind of.
Yeah.
I mean,
But the thing is
the trick is to say, okay, if you're using your indicators, how do you tell whether it's a gradual bow or a specific spot that's bent?
Oh, that was in my mapping here. So I had 9, 14, 17, 8. So I kind of knew exactly where the highest and lowest was. Now let's just say if I had 8 here and 8 here, and it was like only about 9 or 10, I would say, hey, you know, straightening this, then that would make a double cam, right? Okay, so I would go ahead and I would work on these, and I would sometimes I only try to take partial out of it. Let's just say it's 8, and I want to, okay, let's bring it on down to like 3 or so, and this, and then let's recheck the center. So that's why mapping.
At your rollers, you got 0.
Yeah, that's exactly right. No matter what, that's 0 and that's 0 there.
Okay.
If you do a weld repair, you said when you're heating it up, you're watching the gauge.
Yeah.
That's when you know it starts cooling.
Yep.
When it starts climbing.
Yeah.
How far do you let it climb?
That depends on how fast it's going and the size of shafting that I'm working on. That's something that you will learn, and time takes time. No. Yes.
If you do a weld repair on your shaft,
Yep.
should you do your heat treating before or after you do the finished machine?
It depends on how far out it is, and if it's really a wicked bend in the shaft, sometimes I'll put it in a hydraulic press and I'll soft pad it, and I'll push it back to within 30 or so, and then I'll set it up in a weld positioner, and I will preheat it. And then, I would put it in the lathe and undercut it first, where I'm going to weld it. But then I would preheat it, and then I would do the welding on it. And then after I do that, I've got like a post heat. I bring it down slow, rapid, and then I put it in the lathe, and then I rough the rough surface off. Sometimes you can only hang on to it with the chuck and the steady rest, and you can't really catch the center drill out in the end of the shaft because it's still running out, and you just can't. So what I do is I just kind of rough off the diameter to where I know, okay, I got enough weld on there. Then after that, then I set it up and I straighten out, and I straighten before the weld to make the other side of the weld run true, and then you can carry on from there, and then you can come back, then you can put it in the lathe, and then you can machine that without any blems.
What prevents you from just doing this in a hydraulic press?
the hydraulic press, and especially in stainless steel, it has a lot of memory, and you can press it and you can guess it. Okay, I can actually set it here and set it quicker and faster and without any second movements. How many times have you pressed something straight and then you go, oh, now I got to flip it over? You know, so and not to say that you can't, you know, especially when something's working really fast on you, you can have to roll it over and go ahead and heat straighten it on the other side. So I mean, I have had heat marks on each side, especially if it's a little too much the very first time you touch the torch to it. So, you know, so I kind of like touch it first and then find out where it's at and how fast it's going.
You started out checking, you just indicated all the way at different spots, all the way along.
Yep.
They're not relative to each other. If this is a surface plate, which is money, then of course they're all relative. But you're just checking one individual spot at a time to see what it is at one location.
Well,
if this table's out, right?
Yeah.
Assume this is not a perfect surface plate.
Yeah.
You're checking here, and then you move over to here.
Yeah, I'm checking the indicator readout. Yeah.
At one spot. So you really don't know what it is over the length.
No, it's no matter what the length is, supported by two units here, the sag or whatever you're going to consider the weight or whatever is going to be the same no matter where you roll it.
It's only the delta, it's not the absolute.
Yes.
When you mentioned that you're going to press that, you're going to put it in the press and press it. You're not pressing it with those rollers in there too.
No. I usually take and I set these up in front of my actual ram.
Yeah.
Okay, and then I set soft pads, and that's if I need to. That's if you got like a 10-20 degree bend at the end, you know, or something. Yeah. Yeah, no. The work it goes to put in there, and you know, they can handle a lot of weight. I can set a 6 by 12 foot, 6-inch round, 12 foot long shaft on here.
So you can do the same deal on a very short shaft too.
Yes. I have a 3 foot piece over there. If I'm going to do another demo, I'll grab that one. And
Once you had like a foot, like on I've got a drill press.
Yeah.
On the shaft coming down. It's got a,
Yep.
So, you know, it's like that long.
Yeah, it does whatever as long as you can have 2 points of indicating. Sometimes if it's so short and you don't really have 2 round diameters, you can put it in between centers and then you can do it that way. As long as you got 2 points that are 0. Now, sometimes if you might have you can consider it as just the same as under the rollers.
Keith, if you got an axle like in a car that has a bad bearing and it's getting really hot, does that bend the shaft, cause the shaft to bend, or will it cool off naturally?
Yeah, the heat's symmetrical on that axle, and I would presume that it would cool down uniform, and you're not underneath there and only hitting it on one side with a hose. And actually, sometimes when I get going and I'm actually heating one spot or the whatever, and it's getting real close, and then I'll just hold the water on it and I'll spray it, so I'm just making it as uniform as I want, you know, as I can, and then trying to get it to be normalized so that I can come back to it. I'll remap it, take and check it out. But I mean, you're doing several spots, but you don't have to check those same spots. You know, you can come on here. In between, and we only brought that down to a couple there, but down here it starts getting real close.
So after you heated the spot with the torch and you put the cold water on it, that particular area of the shaft is cooling quicker than the basin area.
Yep.
So that's what creates the pulling.
Yep. The center, or the concentration of the heat in the center is cooling down much faster than the surrounding area around the spot.
If I could take some dents out of my car.
Yeah. No, you can if you wanted to. You can expand. You know, you got to expand it on the right side and cool it from the right side to get it to pull that dent out. So, and or you can rent the dinking. Which actually works pretty good.
That's what my wife did. I get to mess it up first and I paid it.
Anybody got any more questions? Bronze, I go into peening, and I work and I peen the opposite side that I would work with the heat. And yeah, and I'm expanding it out, and then I would draw file it, and then I just polish that out. Now these all, you could have regular green Scotch Brite or your brown or whatever Scotch Brite, and these polish right back out and don't do anything to the finish. So if anybody was wondering about the spots themselves.
So you're actually, I didn't see the demo, but you're actually just pinpointing where the gas.
Yeah.
That work for tubing?
Tubing, you're going to need more of a mandrel atmosphere for it because you got kinking aspect. What I do for tubing most of the time is I'll take a 3-jaw or collet, and then I'll run it through there, and then I do just a lot of manual indicating and manual, pulling, and because tubing, it depends on what kind of tubing. I do a lot of outriggers, which is real thin wall aluminum, and I'll straighten that kind of stuff out.
Pulpit stanchions, that kind of stuff.
Yeah.
So you're originally from Southern California? Or?
Yeah, originally I am.
Did you ever spend any time in Hermosa Beach?
What beach?
Hermosa?
Redondo.
Redondo?
Laguna Beach, Cardiff, Carlsbad, Oceanside.
There was a bar there called Fat Face Fenner. It was started by a guy named Keith Fenner.
Okay, no, it wasn't me.
I didn't do it.
Alrighty.